Hello guys, we are discussing about the lab. How do we model the experimental data of adsorption experiment for mass transfer? Is applicable to any experiment you do. So let me share the screen and we'll discuss the basic and then we'll go ahead of step by step. How do you execute the lab? Okay. So we are executing lab of data analysis for to have model for experimental data. So typically we have the data in terms of inputs are x1, x2, x3, anything, and output is y. So if it is only one x and one y, this will go to regression, linear regression. But if you have multiple x and one y, how do you solve it? This is called as multiple linear regression. Now this is typically in form of y equal to a0 x1 raised to power a1 x2 raised to power a2 x3 raised to power a3 like that. This is the final form which is to be put in as your model in a research paper. But actually when you solve it, a multiple linear regression solves it as y equal a0 plus a1 x1 plus a2 x2 plus a3 xt and so on. So this is the way linear regression solves it. This is the way you report it. So first step is how do you convert this form equation 1 into a similar equation which is equation 2. So what you can do, it's very simple. If you apply a log to ln to y and ln to this term a0 x1 a1 x2 a2 x3 what it becomes? It becomes ln y equals ln a0 plus a1 ln x1 plus a2 ln x2 plus a3 ln x3. So equation number 3 would be if you apply ln on both the sides, you're not changing it, but you are changing in a form of equation 2 which is required. So you can be converted this into capital Y equal to capital A0 plus A1 ln x1 could be written capital X1 plus A2 capital ln x2 could be written capital X2 plus A3 ln x3 could be written capital X3. So if you look at this equation 4, this is similar to equation 2, which could be solved with multiple linear regression. This is the basis. So whatever data is you have, the first thing, whatever data you have in x1, x2, x3, and y, you have to convert this into capital X1, capital X2, capital X3, and capital Y, which is ln x1, ln x2, ln x3, and ln y. And then apply your multiple linear regression on this data. Correct? This is the important part of it. Now, first thing is how do you get this data? X1, X2, X3, blah, blah, and Y. So the first thing I want, everybody has to find out one unique research paper on adsorption of dyes. हो चालेल. absorption of dye. Okay. So there are around 17,000 paper available. You have to look it on Google Scholar. Okay. Now I want at least one Y and at least 2X. So you have to extract this data from the paper. Yes. Now for this, you may have to extract data from graph. And once you extract, then you can use this method to find out and get the equation. So now I'll tell you how do you extract data from the paper. So I'll stop sharing this. I'll share. Okay, now you can see this. We have multiple papers. You can see there are 17,000 papers on adsorption of dye. So take any paper. Okay. Now once you take this paper, you will have paper like this. So I will stop sharing this. I have to share another. So you have to go to. So this is a paper you have. Now what you do? You have to copy this article, paste it into something called as Sci-Hub. So everybody knows about Sci-Hub. Everybody knows. So paste this in Sci-Hub. I'll stop sharing and share it again. This is a window. It talks about Sci-Hub. Say open, and it will give you the paper. Now this is the paper you got, correct? Now look at the paper. You will get few data. Yes, this is a basic catalyst. Now here I could see I have this data, which is solution pH versus percent adsorption. So my Y is going to be a percent adsorption. My X could be pH, my X could be initial concentration, my X could be initial catalyst loading. It could be a temperature, it could be RPM, anything. So I want at least two parameters, it could be more. So there is a snipping tool. Just go to snipping tool, crop this graph, save it. So you have to save it as, you can save it as anything you want. I'll just say 1, 2. So I just saved this graph. Now next is, how do you extract the data from this graph, X and Y? For this, you have to use origin. Now for origin, the free version is, one version is free. So you have to register, you just say free version of origin in Google, you will get the version. You have to register with your email, put details, and then you'll be able to download. So one is 2 GB file, one is 700 MB file. So you'll get free access to the origin for 21 days. Correct? Now I'll show you. I already opened. You can go to Google, YouTube, and find out how do you extract data from origins. You can see how to extract data from a graph, image digitizer origin pro. So this is a video which will help you. Just Google out, help you. You can go through the video. You will know how do you extract data from origin. This I am not covering. Okay. So you have to first download. Don't give me excuse, sir. I don't have a. It's a freeware. You have to register with your VIT email and download 700 MB. Set it. You require a key. So you have to send click on a link which will send a key to your Gmail, your VIT email. Get that key, activate the product. And how to use the product would be given here. Correct? So this video will tell you in detail how do you step by step go and get. So after this video, yes. So this is a video which tells you step by step, every step, how do you extract. See, now they have cropped it. After copying, it is saved and it is, you open the software origin and follow the step. It's very, very easy. Follow the step and you'll be able to extract the data. Okay. So this part I'm skipping. We'll go back now. Once you got the data, how do you go ahead and solve it? So I'll tell you now step by step. So what you have done, we have Google out free origin software. You have to put your VIT email, state reason I am a student, I want to use it for research. These options are there. Then you can able to download around 700 MB file. Okay. Then you have to set it, run with admin. Then it will ask you for license file. So this license file would be emailed to your VIT email. Copy it, paste it, and origin is done. It's very useful software. You will get 21 days license. So very wonderful. Okay. Now next, I have put up, you can go to YouTube, Google out how to extract data from graph in origin. ORIGIN. So this will give you the details. So we are going to a next step now. You got a data of x1, y1, x2, y2, x3, y3. So you require at least two. I want you to work on at least two. More better. Okay. So now you have a data of x1, x2, but in y you have y1, y2. So you can define the weightage of this y1, y2. Let's say y1 is more valuable or more important than y2. Then you can put a parameter, or I say I just want to take average. So I'll say y1 into 0.5 plus y2 into 0.5. So this will give you data of x1, x2, y. Clear? So we got three data sets. So now I tell you how do you exercise, how do you solve this in Excel. So I'm sharing a screen. So here I have taken a data which is x1, y1 data. It was there, so I just copied it. So data was like this: x1, y1, x1, y2. So I have written x1, x1, x2, y. So y I have taken average here. So it could be average or it could be, so you can look at this, average of two y's. So you can define your logic and go ahead. So number of rows should be same. Now you have to apply this. So what is the first step? Converting this into capital X1, capital X2, capital Y. How do you do it? ln of X1. Drag it down, equal ln of X2. Sorry, something has gone wrong. You have to do ln of one number, not. So ln of X2. Okay. This you got. Drag it down. Get it back. Okay. Equal ln of Y. Okay. So we got X1, X2, Y. Clear? Now you required a very important something called as data analysis tool to use linear regression. So you have to go to file, then options, there is action of add-ins. In add-in, you can see when you say add-in, there's an option of analysis tool pack. So you have to go to this, activate this. I already activated this analysis tool pack. That's why it is not showing. This is an active application. Tool pack is an active application. So I say okay, and it is done. So in data, you can see a tab. Just a minute. So when I go to data, I can see the tab of data analysis. So you should be able to see this tab called as data analysis. Okay. So now I have to use this data analysis. So I select this. I go to data. I go to data analysis. And I select regression. Say okay. This window opens. Input range. So Y range is only one. So I select Y. Whereas in X, you have multiple ranges, 2X. So I can select these two. And I say okay. When I say okay, you can see there are various. I'll just put this so you know. This is the output data I have. Correct. Now you can see there are three variables: intercept, X variable, X variable. So I just put it here. This is of my interest. Now this will be capital A0. This would be small a1, small a2. Yes, you remember? ln a0 plus a1 ln x1 plus a2 ln x2 plus a3 ln x3. So ln x1 ln x2 has becomes capital X1 capital X2. So first ln a0 small a0 would be a0 capital A0 and a1 a2 you are directly getting. Yes. So now I want small a0. So how do you find out small a0? Capital A0, it was A0 equals ln of small a0. So if I want to find out a0, it will be exponential of capital A0. Correct? So I can find this value by finding the exponential of this value. You have to make a bracket, exponential So A0 is this, and A1, A2 would be this value as it is. Correct? So we have now A0, A1, A2. How do you know these are correct? There's a way to check it. You can find out Y, capital Y. What is capital Y? A0 plus A1 into X1 plus A2 into X2. Oh. So instead of A0, instead of putting a value, I have put a alphabet. That's why it's given error. Okay, instead of putting A2, I have put up alphabet A2. So A2. Okay. So it seems there is some problem. Here it was supposed to be. Okay, so what values I have put up? A0 value, I am checking out the initial one. So it should be a capital. Yes. So you can see whatever I just trying to see whether the values I got is correct. So I'm just trying to reproduce with this equation y equal to A0 plus A1 X1 plus A2 X2, the converted one after ln. So I'm just trying to check out whether my values are correct. So I just put up all the values I obtained and this value, I put up this value and I got the equation. It means it's correct. I'll just check out whether the other values are correct. Now you can see I'm just getting first value correct, but others are wrong. Why? Because I did not put this in this A0 in this equation. A0, A1, A2 are constant. I did not put it constant. So I have to put it constant. How do I put it constant? By putting dollar across the alphabet. So I am just putting the alphabet and here I go. Now, once they are constant, I will be able to reproduce. Are you able to get it? Now, one thing I have made a wrong. Let's see what has gone wrong. Okay, that is correct. The variation. So R square is 0.89. So you can expect this error because R square is not fitting very well. It is fitting 90%. Normally, if it is 0.99, then you can expect the exact result. So it's correct. So now I want to get an equation, the original equation, small y equals to A0 into x1 to the power small a1 into x2 to the power small x2. Yes. So I want to check out this column small y with y predicted, which is smaller y. So I'll put this y equal to small a0, small a0. This is a constant. So I am putting this as a dollar into small x1 to the power a1. Now a1 is constant. So I am putting a dollar across into x2 to the power a2. Okay. So you can see I can match this Now what I do, I want to predict how nicely it is matching. So I plot something called as parity plot. There's a technical way you are trying to see how best your model is. So how do you predict? So you need to have prediction, experimental versus prediction. So Y is the experimental, which is the original data. Yes. So I am trying to predict experimental versus predicted. So I want to draw a graph now. So I am trying to fit this as a linear curve at trend line. Want linear. I want this display R value. That's it. So you can see my R, because my prediction Y was not good. So I am also getting this prediction not very good. So this is called as parity plot. Okay. So you can see this data is not fitted well, but I am trying to put a model somehow. No model is available. At least I am trying to have some correlation. So this is appreciated. You can put a name. You can go to chart design where you can put a title axis. So this was this is Y experimental, and this side Y predicted. So that's why we have a parity plot, and the equation which tells you with this would be small y equals 25.3852 into x1 to the power minus 0.5035 1 into x2 to the power 0.435188. So this would be a model which is going to predict your data. This is a final model. Okay. So that's why you have to do the whole exercise. Yes. So your conclusion would be this model, and at what accuracy, the R square, what accuracy your model fits. So your R square is fit within 71.4%. Okay, R square is 0.7148. Okay. So that's the whole thing is going to come as the conclusion. So you have to do this whole experiment as mentioned. Okay. Thank you.